Good afternoon, students. Today I am dealing with one more relation. That one is nothing but electrochemical cell, electrochemical cell, and gives free energy change. Gives free energy change. Gives free energy change. So that is nothing but delta Z naught. So already you know that electrochemical cell, that is nothing but galvanic cell. Fine, galvanic cell. It is used for, that is used as a source of electrical energy. Source of electrical energy. It is a source of electrical energy, and it is used for different kinds of work. It is used for different kinds of work. Different kinds of work. Kinds of work, right? So means here that electrical energy is quantitatively converted into work. So therefore that electrical energy or electrical work, it is a product of EMF and charge flowing through the external wire. Charge flowing through the external wire. Charge flowing through the external wire in this case. Fine. So that is galvanic cell. It is used for that. It is used as a source of electrical energy, and it is used for different kinds of work. Means that whatever that electrical energy that is quantitatively converted into different, that is a work in this case. That electrical work is nothing but EMF, product of EMF and charge flowing through the external. So for the transfer of 1 mole of electrons, 1 mole of electrons, for the transfer of 1 mole of electrons, 1 Faraday electricity is required. 1 Faraday is nothing but 96,500 coulombs of electricity is required. But if there are n moles of electrons, then charge required should be a NF in this case. Okay. Similarly, that EMF is nothing but, it can be written as EMF is nothing but E cell. EMF is equal to E cell. So therefore that electrical work can be written as, that is E cell into NF in this case. Right? So call this equation as number 1 in this case. Means in this case what happens, this is a electrical work, that is it is a product of EMF and charge flowing through the external wire. For the transfer of 1 mole of electrons, so 1 Faraday of electricity is required, that is nothing but 96,500 coulombs of electricity is required. So if there are n moles of electron, the charge required should be a NF in this case. And EMF can be written as E cell. Therefore electrical work is nothing but, it is a product of EMF of a cell and n number of charges flowing through the wire either. So already we know that from the concept of thermodynamics. Okay, so if any spontaneous process occurring at constant pressure and temperature, the driving force for this type of process is a decrease of a free energy. Okay. Decrease of a free energy. Decrease of free energy. Okay. So that is nothing but, it is commonly known as, means if any process occurring, that is spontaneously occurring, on that time there is a decrease of a free energy. Similarly in case of an electrochemical cell, the driving force for that electrical work is, similarly for electrochemical cell, the driving force is again the same in this case. Therefore the decrease of free energy, is equal to electrical work in this case. Okay. So means any spontaneous process that is occurring at constant temperature and pressure, the driving force for that such type of process is, that is a decrease of a free energy. Similarly, in case of electrochemical cell, because it is used for different kinds of work, therefore in this case also the electrical work is equal to, that is a decrease of a free energy in this case. So this call this equation as number 2. Okay, so therefore, so comparing 1 and 2 now, comparing 1 and 2, so what happens? So electrical work is equal to this much, so delta G, so minus delta G is equal to N F E of a cell in this case, or this can be written as, in standard conditions, E delta Z naught is equal to N F E naught of a cell. So this is a relationship between electrochemical cell and gives free energy cell. That is a decrease of a free energy change. It is used for the different kinds of a work. So therefore the driving force in case of a electrical work is nothing but again a decrease of a free. What is the significance of this equation? So what is the significance of this equation is, so it can help in predicting the spontaneity of a process or feasibility of a process. It can help in predicting the feasibility of a process. So if the process is feasible, delta G must be negative. If this may be negative, then E must be positive. On that case, the process is feasible, or it is also called, on that case, delta G must be negative. So this is about the relationship between electrochemical cell and Gibbs free energy change. So next one is that is a relation between standard EMF and equilibrium constant Kc. Okay, so this one is second relation between EMF and Kc. So based on that thermodynamics, already you have studied in maybe in a PUC first year, delta Z naught is equal to minus RT ln Kc. Okay, so based on that previous equation, delta Z naught is equal to NF E naught is equal to minus RT ln Kc. Okay, so therefore E naught is equal to RT by NF Kc ln Kc. So here that negative sign, negative get cancelled. So therefore E naught of cell is equal to which one, 2.303 RT divided by NF log of Kc. Okay, so therefore E naught of cell is equal to, again if you put the standard conditions, 2.303, R is 8.314, temperature is 298 Kelvin, and as it is based on the reaction, and F is, that is 96,500. So then log of Kc then. Okay, so therefore if you calculate this one, it becomes 0.0591, okay, divided by N, then log of Kc. So this one is E naught of cell. So this is a second relationship between standard EMF of a cell as well as equilibrium constant. This is the second. The first one is delta Z naught is equal to minus, so that one is relationship between electrochemical cell and standard Gibbs free energy cell, and this one is second relation, that one is a standard EMF and that equilibrium constants. So based on this one we will solve some of the problem. So that is the first problem. Calculate standard electrode potential, the standard electrode potential of linear cell, the standard electrode potential the standard electrode potential of DNL cell is 1.1 volt. Calculate the standard gives free energy. Standard gives free energy change. Standard gives an energy change of the reaction. So this one is a reaction, that is zinc, it becomes solid state, and copper, it becomes aqueous. Then it undergo reaction, it becomes Zn2 plus, again it is aqueous, then it becomes copper, it becomes solid. Okay, so the solution for this problem is, so here in the problem the standard electrode potential of DNL is given, it is 1.1 volt. Okay, so you need to calculate the standard gives free energy change, that is delta Z naught of the reaction. So this one is redox reaction, that is galvanic cell reaction. So already you know the relation, delta Z naught is equal to minus NF E naught, fine, as NF E naught. Okay, so that one is, you need to calculate delta Z naught. So N is nothing but there are two electrons involved in this reaction, because Zn to Zn 0 2 plus 2, here also copper 2 to copper, so therefore minus 2. F is again a constant value, that is 96,500. so the standard EMF of a cell is given, it is 1.1 volt. So that is nothing but minus 2.2 into 96,500. So this is nothing but 212,300 joules per mole, right? Or this can be written as minus 212,300 kilojoule per mole. So this one is the answer for this type of an example. Okay, in the second problem now, the standard EMF, the standard EMF, that is E naught of a cell, standard EMF of cell reaction, this one is a cell reaction, Sn4 plus, that is chromium, it becomes Sn2 plus, and it becomes chromium 3 plus. So this becomes 3, then 2, it becomes 2. Okay, is 0.89 volt, it becomes 89 volt. Okay, so what is the value of delta Z naught? Okay, so again the same relation, so here the standard EMF of cell reaction is given, that one is 0.891. What is the delta Z naught value? So delta Z, you know the relation, delta Z naught is equal to minus NF E naught. Okay, so here the important thing is, you need to find out the N value, that is number of electron transfer during the reaction. So therefore the N is equal to 6 in this case. There are 6 electrons involved in this reaction, therefore it becomes 6 into 96,500 into 0.89 volt. So this is equal to minus 515,310 joules per mole, or this can be written as minus 515.310 kilojoules per mole. Okay, this is about the second problem. Next one is third problem. So calculate third problem, calculate the value of LV of Kc and delta Z naught for the following reaction, for the following reaction so this one is a reaction Mg, that is magnesium solid, then copper aqueous, then Mg2 plus aqueous, then copper solid. So the EMF of a cell is given is 2.71 volt. So you have to calculate Kc as well as delta Z naught. So already you know the relationship between which one, EMF as well as ln Kc. So EMF of a cell is equal to 0.0591 n divided by n log Kc. Okay, so already it is given, E naught of cell is given, that is 2.71 volt, 0.0591, that is n values 2, in this case 2 electrons are involved in this reaction, then log of Kc, or this can be written as log Kc is equal to 2.71 into 2 divided by 0.0591, or this one is nothing but Kc is equal to anti-log of 90.70. If you calculate this one, you will get this answer, 91.70 as the answer. So if you see the anti-log of this one, you will get as 7.318 into 10 raised to 91 as the answer for a equilibrium constant. So second question is you have to calculate delta Z naught. So delta Z naught, you know the relation, delta Z naught is equal to minus NF E naught of a cell. Okay, so N is again 2 electrons are involved, F is 96,500, then EMF of a cell is given 2.71 volt in this case. So if you calculate this one, you will get 523030 joules per mole. Okay, so if you calculate this one, again it can be written as 030 kilojoules per mole. Right. So this is about, that is the third problem, that is you have to calculate Kc as well as change in free energy for this type of law. So based on that relations, EMF and equilibrium constant as well as change in free energy and EMF of cell reaction, so you can calculate both in this case. And third problem now, that is not, sorry, it is a fourth problem now. So in the fourth problem, calculate the delta Z naught for the reaction, the delta Z naught, that is standard free energy change for the reaction, for the cell reaction. Okay, so this one is given Zn2 plus, so the concentration is given 4 into 10 raised to minus 4 molar. This is again salt breeze, then cadmium 2 plus, the concentration is 0.2 molar. Okay, then it becomes cadmium. Okay, so given is, these are the given values given. So E naught of which one, Zn2 plus bar Zn, it becomes 0.76 volt. Okay, then E naught of cadmium 2 plus bar cadmium is equal to minus 0.40 volt. Okay. So first you have to calculate which one, that E naught of a cell. Okay, so therefore the solution for this one, because both will have a different concentration, so therefore first you have to calculate E naught of a cell. So E naught of cell is equal to, already you know that EMF of a cathode minus EMF of a anode. Okay, but the EMF value in this case, for the cadmium it is, that is more in this case, because it is a less negative, but if you if it is more value, so the more value can be act as a cathode. So therefore minus 0.40 minus, then it becomes minus of 0.76 volt. Okay, so here zinc will act as an anode and cadmium will act as so based on that electrode potential, you can the value which the electrode potential value which is more, that should be act as cathode. The value of electrode potential which is less, that one act as anode. So therefore it can be written as 0.40 plus of 0.76 volt, or this can be written as, that is plus of 0.36 volt. So this is, that is 0.36 volt as a E naught of a cell. So already you know the relationship. EM of a cell is equal, that is Nernst equation. EM of a cell is equal to, that is which one, E naught of a cell, fine, then plus of 0.0591 divided by n log of, so it can be written as cadmium 2 plus, concentration of cadmium 2 plus, and concentration of Zn2 plus. Here the concentration of Zn and concentration of this cadmium should be unity because both are in a solid state. Therefore E naught of cell you have calculated, that is 0.36 volt, then 0.0591 divided by 2 because 2 electrons involved in the reaction, then log of the concentration of, that is cadmium is 0.2, okay, then the concentration of Zn2 plus, that can be written as 0.0004, right? So therefore E naught is equal to 0.36 volt, then 0.0591 divided by 2, then that is log of 0.2 divided by 0.004. So this is equal to 0.360. If you calculate this one, 0.02955, then log of this term is nothing but into 2.6989. Okay. So therefore it is 0.36, and if you calculate this one, you will get 0.0797. So this is nothing but 0.43975 volt. So this one is about EM of a cell. But in the problem they have asked to calculate which one, delta Z naught. So therefore delta Z naught is equal to minus NF E naught. Okay. So minus N is nothing but, here again 2 electrons are involved, then into 96,500 and into 0.43975. Fine. So if you calculate this one, you will get 84,871.5 joules per mole, or this can be written as minus 84.871 kilojoule per mole. Okay, so in this problem they have given only which one, E naught of a respective reactants like a Zn2 plus as well as a cadmium. So you have to calculate E naught of a cell. So once you know the E naught of a cell, do not add that E naught of a cell directly because both the solutions will have a different concentration. Therefore you have to calculate the EM of a cell by using a Nernst equation, this equation. So once you know the E naught of a cell, so you can put this value in this equation, that is change in free energy against versus E naught of a cell. So finally we will get this equation, this which one, answer, that one is the delta Z naught is equal to 84.871 kilojoule per mole as the answer.